Well, hello, welcome to our webinar. I'm Lisa Anderson, President of the Association for Supply Chain Management for the Inland Empire, and also the President of LMA Consulting Group, a firm that works with manufacturers and specializes in supply chain management. So I am here today with Alan Dunn. We are excited to have Alan join our series, our Emerging with Supply Chain Strength series. Actually, stay tuned because in 2023, we're going to be launching another webinar series for where we're going in the future. And that's where Alan's going to kick us off on just that topic. Our topic today is absolutely critical. I couldn't think of anything more appropriate than what is coming. The global supply chain challenges between 2022 and 2027. And we'll have to ask Alan why he picked 2027 as an end date. But nevertheless, it's quite the challenge just to think about where things are going and to keep up with all the changes. So we're really thrilled to have Alan Dunn with us today. Alan Dunn was the 2015 APICS Board of Directors Chairman, so he has certainly something in common with all of us. He also serves as president of GDI Consulting and Training Company, and is founder of the Manufacturing Executive Institute, a manufacturing industry training provider with state-of-the-art classroom and web-enabled training facilities in Southern California. Alan is also the creator and lead instructor of the 18 to 22-month Next Generation Global Supply Chain Leadership Development Program at California Institute of Technology's Center for Technology and Management Education, which is Caltech. So that very much leading us into the future with students as well. So that's why we've always had a lot in common here. I could go on and on, but Alan is definitely an expert in strategic planning, supply chain management, manufacturing, and so on. He was previously vice president at Gemini Management Consulting and partner at Coopers & Lybrand, which is now known as PricewaterhouseCoopers. He's got a wealth of experience, and I am thrilled to have him here with us today. So with that said, Alan, we'll go ahead and turn it over to you. If anyone has questions while Alan's bringing up his slides, make sure to put them in the chat or the Q&A box, and I will feed them to Alan as we go along or at intervals when we can fit them in. So, all right, Alan, go ahead. And I see that your screen is starting to share anyway.
Yep, there we go. Trying to fix that. Okay. All right, well, let's get started and let's talk a little bit about this and talk about what's really going to happen in the next 5 years. By the way, Lisa asked the question about why did I pick 2027? And it was just because it was a good 5 years. I have to tell you something, and for those of you dialed in earlier and were listening to Lisa and myself chat a little bit, you heard me say that some days, in fact, most days I wake up and read something about supply chain and I say, I didn't see that coming. And so the problem that we have is that almost nothing is predictable anymore. And this is becoming very, very complex and very difficult for a lot of us to be able to even operate in the supply chain world. And so if we really talk about supply chain we have to remember is made up of a number of major elements, 15 to be specific. So there's your tier 1, 2, 3, et cetera suppliers that feed an inbound transportation capability to perhaps an inbound intermediary or a distribution center to a secondary transportation, oftentimes referred to as last mile, into your warehouse. And that's where you store your raw material. And then you take that raw material and you provision for it, which means you plan for it, you schedule, you try to do everything that you can to run an efficient factory, and then you manufacture it, and you have to, of course, manufacture to a certain quality level. And it may not just be you manufacturing, it may be co-manufacturers, it may be other plants, multiple plants, et cetera. So there may be a lot of other partners in the manufacturing arena. And then you send it off to finished goods, hopefully for a very short period of time before you ship it out the door. And then it goes back through an outbound logistics loop. So you've got the primary outbound transportation, then it may go to a distribution center or to a break bulk center. Obviously, some of you, if you're going direct to a customer, you bypass that. But if you do go through a distribution center on the way out or any sort of channel intermediary, then you end up having to have that last mile again to the customer. And then there's that customer consumer interface where you actually get it to the consumer. So if I'm a Mars company and I'm selling candy bars to Costco, Costco is my customer, but they're not my consumer. My consumer, of course, are the retail customers. So there's that connection or that conversion from customer value or customer utility to consumer value, consumer utility. And then along came Amazon, and we ended up building a whole profession around return logistics. In fact, one of the fastest growing elements of supply chain management is how to manage returns. And that's because customers oftentimes from these big channel intermediaries like Amazon and others, and that's what Amazon is, by the way. It is not a manufacturer, it is not an OEM, it is a channel intermediary that makes deals with both their suppliers and with their customers and consumers. And so they, in fact, create a real channel opportunity. And because of that, they oftentimes have customers that buy multiple sizes of things or multiple alternate solutions to a problem. I know when we were building out our recent new studio that we built, we oftentimes would order 7 different cable lengths for a particular cable and return 6 of them because we weren't really sure which was going to work best when you're done bending it around things. So return logistics has become enormously important. So a global supply chain leader, all of us in global supply chain need to understand all of these elements. And when you look at this, it turns out that most people in a company work somewhere in supply chain because it includes all of distribution, all of quality, all of manufacturing, all of planning. It includes a huge amount of employees. And then when you reach out to your tier 1, tier 2, tier 3, tier X suppliers, you kind of add even more in there. So supply chain spends most of the money of a manufacturing company. Now, the world has changed around us dramatically. So globalization of trade has been moving forward for probably about 40 years. In a rapid way since December 11 of 2001, 9/11 of 2001, we all remember that day, and none of us will ever forget that. December 11 is when China was admitted to the World Trade Organization. And when they came into the WTO, that began the acceleration of change, because after that, other countries came in as well. And then, of course, China just dominated in so many markets. So globalization of trade is here to stay. There's some attempts to nationalize at certain levels, but ultimately we all live in a global economy. And as they say, that cat's out of the bag and it's not going back in. The sovereign supply chain is a developing technique. We wrote a paper a number of years ago on that, continue to publish about that. And that's about countries recognizing there are things that are important to them that they shouldn't have others manufacture. They should not allow outside their sovereign bounds for the supply. So there's some growth in that, although it's never going to be an enormous growth, because the alternative to worrying about, say in America, China shutting down the ability to buy N95 masks in North America is to just have suppliers in 5 or 6 different countries in the world. So in other words, a suite of alternate suppliers is an option or as an alternative to the sovereignty or the worried about sovereign supply chains. Technology, of course, is changing, and that's what we're going to talk a lot about in this program. But more important than technology is the convergence of technologies. It's the speed of technology development has definitely changed. The CEO of NVIDIA says Moore's law no longer works. We don't double computational power every 18 months, but we're doubling it about every 6 months now. And now we have, because I teach at Caltech, I talked to a lot of the quantum computational folks, and now we're getting very, very close to the commercialization of quantum computers, which is the equivalent today of taking your fastest computer and comparing it to a 1978 Radio Shack computer, TRS-80 computer. So we're going to make another enormous leap very soon. And the convergence of the technologies is where the real payback is going to come. And we're going to talk about that, the convergence in technologies. Kind of what I call a moment of wisdom is to recognize the future of global supply chains is not as much about technology alone in the individual technology as it is about the convergence of technology. My next slide, I'll explain that a little bit more, but we really have 4 major technology enablers. We have sensor, and sensor costs have come down 100-fold in 3 years. So this is whether it's vibration sensors or humidity sensors or other telemetry type of sensors. Sensor technology has come down. I was just talking with some folks over at a company that makes oxygen sensors that are used in a lot of what they call transcutaneous oxygen measurements, where they put a patch on your skin and they can measure. And the cost of those have come down over 100x in 3 years, because now they're effectively printing them rather than making them like a semiconductor. It's very interesting technology, and this grayscale lithography that has changed everything in that world. So the less expensive the sensors are, the more sensors you can have. The more sensors you have, the more intelligence you can get out of your operating systems in your factories, on your equipment, on your transportation modes, and a lot of other things, including visual recognition systems and those sort of things. Then the ability to manage all that data and separate the noise from the really important few pieces of information. That's really what artificial intelligence is largely about. But what really enhances that is convergence of artificial intelligence with machine learning. So artificial intelligence is based on, it's what we refer to based decision system, not a parameter driven sort of system. And what machine learning does is it learns from prior mistakes. It also gives the ability to learn from others if there's a network available to dial into. Indeed, that's what the IBM's Watson computer is all about. Every day, any published medical article, it consumes that and it sorts through it and it tries to understand it. And so when you as a doctor, if you want to do a diagnosis of some problem that a human has that has walked into your office, Watson is now to the point where it not only, if you give it all the symptoms, it can go through and not only the traditional medical knowledge, but anything that might have been published last night in Sri Lanka. And so it goes through and it looks for that, and it helps the doctors by providing alternate diagnostic steps to start to narrow it down. So the convergence of artificial intelligence and machine learning accelerates the diagnostic process through the process of elimination. And then to be able to get that to everybody, to every individual, to a machine, to everybody in the supply chain, that's what connectivity is about. That's what 5G is about. That's what wireless is about. It's the ability to be able to do this wherever you are. Now, if you take a look, this has to be supported by enormous computational capabilities. So these are kind of what we refer to as the derived useful technologies that make this work better. So just as all of us know, a faster processor in your computer and more memory in your computer and a solid state drive dramatically speeds up your computer. So anybody who has a laptop or a desktop, knows to just load it up with as much of that as you possibly can, and it can speed things up dramatically. The enemy of that, of course, is heat. The faster they go, the hotter everything gets. So there has to be other technologies, thermal technologies, to reduce that. All of that's within the concept of computational leadership and computational management. And the four elements that really makes this useful is that communications, because of wireless and Bluetooth and those sorts of technologies, is becoming ubiquitous. It's becoming easier to attach, to use. It's easier to connect to a wireless device than ever before. And then we have materials. Materials is another technology. So we now have all kinds of different new technologies from in material sciences that change thermal characteristics that are lighter, that are stronger, and things like that. So certainly composites and carbon composites has become a big issue, to the point where it's actually reduced the amount of titanium needed in industry, particularly the aerospace and defense industry, has actually was looking at an enormous shortage of titanium, but an alternate technology called carbon composites has now reduced the need for technology or for titanium. There's still a lot of it needed, but it's reduced that and taken it out of what we call the critical category. And then the ability for things to move better and to move autonomously, or to at least move in an automated sort of fashion. So huge inroads and huge shifts in technologies. And largely those shifts are the result of really managing the algorithm. So Dr. Ames, Andrew Ames at Caltech, who runs a spectacular lab, has built a number of semi-autonomous and autonomous robots. Um, and one of the things he talks about is that there's no reason to make the robot smart until you can keep it from falling over or tripping over itself. And so it turns out that the heavy lifting in robot movement are algorithms, hundreds of thousands of algorithms that help the robot to manage every possible terrain-induced, weather-induced, self-induced sort of balance problem. And so his lab is pretty much focused on that. Another doctor, Dr. Sun Tzu, who's at Caltech, he's really trying to figure out how to make robots do all kinds of different things. So he's actually developed the first walking and flying robot. So if it comes to an obstacle it can't get over or around, it just flies over it. And so it's kind of a quadcopter, meets 3CPO. It's an interesting sort of idea. And so the material sciences is what really makes that motive possible, because you have to be able to manage that, manage all that motion, and you have to do it with as less weight as possible. It turns out the secondary issue on robots, and we'll talk about this in industrial robots in a minute, is that you have to figure out how to power them. So a robot sitting in a factory moving part A from location X to location Y, that's probably plugged into the grid. It's probably not a problem. But if you have mobile robots, or what we call functionoids, these are walking robots that can go from one area to another, or the driving robots, you have to have batteries of some form. So battery technology is really, really important to industrial motive or mobile robots. We have one at Caltech that can walk around the campus for about 4 hours. They take tours with it for about 4 hours, and it runs on 2 cell phone batteries. That's all it runs on, 2 cell phone batteries. That means every little DC micro motor has to be very, very efficient. And so that's been one of the issues. So energy then falls into this as well. So communications, materials, motive, and energy, these are really key contributors to where we're going to be going in material handling. And you're going to see a lot over the next 5 years. You're going to see an awful lot of improvements in material handling as a result of these convergences. So if you really take a look at the convergence, or the elements that have to be converged, we start with big data, the ability to manage massive amounts of data, the ability to understand it and to separate much like Pareto, the important few from the trivial many data elements. As one professor we've talked to at another university has said, is that you have to not only figure out how to connect the dots, but you have to figure out where the non-dots are. In other words, you have to find not only the patterns of data, and we see this in forecasting technology all the time, but you also have to explore the non-patterns, because from exploring the non-patterns, you start to learn about anomalies. Anomaly is just is a scientific word we use in supply chain. We call it risk. So it's the non-dots that point out the anomalies, which point out the potential risks. That's how we really understand the range of possibilities of a market reacting, or of a robot making a mistake or going down the wrong path or something like that. So artificial intelligence and machine learning we talked about before. On the other side is we have virtual reality. You've all seen virtual reality goggles. Most of them are used in the gaming industry. But in industry, we're starting to actually see, in manufacturing distribution, we're seeing, and in training, by the way, we're seeing huge opportunities for augmented reality. So augmented reality keeps you in an artificial state, but not 100%. So it's the ability to see through. So if you think about Pokemon Go, if anybody's familiar, most people are, with Pokemon Go, you're looking through your camera, you're looking at the screen, the lens is activated, the camera is activated, and then there are superficial figures that come up over the reality that you're looking at. Virtual reality is you lock out the reality around you and you put yourself in a new reality. And this is what the metaverse is all about. And some people complained that Mr. Zuckerberg has worked too hard on the metaverse, but it may be the wrong time. That ability to create training scenarios in a fully virtual reality environment can be used in so many places, including training of people on assembly lines, production lines, quality assurance inspections, safety training, where you want to create an alternate or a virtual reality where a person can make an enormous mistake and not suffer the consequences. So the whole simulation sciences, the whole simulation or simulator industry is going to change dramatically from that. And all of this leads us to really understanding about enhanced automation and how to enhance talent. Because if you think about this, a lot of what we're talking about is the ability to enhance talent. In the middle, we end up with this word called automation. Automation, I did not create that word. That was created many, many years ago. Automation is the ability to automate and have it run in an autonomous fashion. In other words, self-directing, self-learning. The convergences that I talked about are the convergence in big data analytics with AI and MI. That's one big convergence, and there's a dozen substantial companies working on that and have all kinds of products available. Another convergence is the blockchain ledgers with ERP and all these operating systems. So the ability to eliminate layers of approvals and layers of information transfer in our enterprise resource planning environments and have it go through blockchain networks, which means it can't be changed, it can't be messed with. It's all, of course, this is what's behind most cryptocurrencies, which, with a few exceptions, have been far safer than traditional banking transactions. And the third one is this convergence of augmented and virtual reality, and using that in the right place at the right time, the right thing. So all of this is really what feeds kind of this automation. So let's talk about how automation impacts us in supply chain. So we're going to talk about material handling, transportation, robotics, repetitive task automation, decision making. And by the way, everything I'm going to show you exists today. I'll point out where it exists in prototypes or it exists in real production and real use. And this changes almost on a weekly basis. So I'll give you the updates as we go along on this. So the first one is material handling. We have to eliminate this paradigm in our mind around fork trucks and around conveyor belts. Now, fork trucks have historically been, and if you don't believe me, talk to any OSHA inspector. Fork trucks are generally one of the most dangerous pieces of equipment in any factory or any distribution center. By volume, there's more fork truck OSHA claims than there are any other category of claims. Not necessarily by severity, although there have been plenty of severe and actually deaths involved with the use of fork trucks. But the problem is a fork truck is a big lumbering device that exists primarily to move things vertically, but 80% of everything a fork truck does is moving things horizontally. So you're basically using a tool incorrectly in most cases. And of course, the danger is there as well. The top left picture, this is a bunch of conveyors. And the problem with the good thing about conveyors is they have a substantially faster speed than any automated guided vehicle or AGV. But they're not nearly as flexible. And oftentimes the speed that they're capable of running is not necessary. The AGVs, and you see over to the right, here's some standard pallet trucks. One's a man aboard and the other is a non-man aboard, but both of them have been retrofitted with AGV capabilities so they can both drive autonomously through your factory. The injury rate is extremely low because they have more sensors, what they refer to as spherical sensors all over the place, typically motion and proximity sensors, than the human has, because the human only has 2 eyes and 2 ears. And so these have the ability to know, most of them have the ability to set range warnings anywhere from 5 feet to 50 feet. And so they generally know of a problem before the operator does. This technology, by the way, out of the AGV industry, found its way into the auto industry, and anybody who has a car that's been made in the last 4 years knows if you have a backup camera system on there, most of you have a warning if somebody behind you that's not even inside of your mirrors is heading down the aisle, particularly far behind you, to warn you that somebody's coming your way. And so that proximity technology actually came out of the AGV technology that was developed in a number of universities. Another big problem with fork trucks is that they use battery, mostly lead acid batteries. There's a few lithium, but most of them are lead acid batteries. They're big, they're heavy. For every fork truck, you generally need 2 batteries, one to be charged while one is running. If you run 3 shifts a day, that may be 2 batteries charging while one is running in the fork truck. And of course, when you put these batteries on charge, you have to have it in an area that's safe because hydrogen and hydrogen sulfide fumes come off of these trucks. So you need to have a safe area for those, and you need a lot of batteries. And these batteries are very, very expensive. Versus what by the way, it could take 8 to 10 hours to charge. Even on a fast charge, you might be able to do it in 3 hours. Problem with fast charging is you also deteriorate the life, especially if it's a lead acid battery, you deteriorate its life at an accelerated rate if you constantly do fast charging. Move over to the right picture there and you see a hydrogen fueling station. Each one of those fork trucks behind it, that's a hydrogen fuel cell in there. I'll explain that in a second, what those are about. And it takes about 3 minutes to fill up. So you pull up to this thing, and that's a hydrogen pump, if you will. And it pumps that tank on that fork truck full of high pressure hydrogen. Hydrogen is not as dangerous. In fact, it's actually less dangerous than gasoline for a variety of reasons. The single biggest technical reason is that it flashes off very, very quickly. So if you puncture the tank, and most tanks are not capable of being punctured. So the Mirai car, gosh, help me out, I think it's produced by Honda, maybe Toyota, has a tank on it that's pumped up to over 4,000 PSI. And if you took a railroad spike and a big hammer and a big bout, you probably could not put a hole in it because it's a glass tank wrapped in carbon fiber and very, very difficult, maybe even wrapped with aluminum. Problem with hydrogen is it goes through metal. The molecules of hydrogen are very small, so you can't put it in a metal tank. So you have to have a glass tank of some form. Nevertheless, a company called Ballard Power Systems up in Vancouver perfected and of course patented the hydrogen fuel tank. So this is not a problem anymore. So now you have a fork truck, you pull up, and in 2 to 5 minutes you're fueled up, and then you go on your day. Hydrogen fuel cells are pretty interesting. Coming in the left side is hydrogen, coming in the right side is just air. They go across this gas diffusion layer. Now hydrogen is H2, so 2 molecules of hydrogen. It goes across, it splits. What it does is it splits off the protons out of that hit the catalyst, usually a platinum-based catalyst, and then up it goes up, and you capture the electricity from it, strips off the electrons too. It goes up and out the tailpipe. Is air and water vapor. And in warehouses, so Walmart has hundreds of these in a couple of their warehouses, and they've put heat exchangers on them so they convert that water vapor to either cooling or to heating, and they can actually change their electric bill in their big warehouses. So the fuel stack takes about 5 minutes. Charge takes 4 to 8 hours. If you want to know more about it, by the way, hold up your phone and take a shot of that QR code. And you can go to and read a little bit more about this from some industry journals that we've linked to this. So replacing the fork truck, you've all seen these. Walmart, of course, is also working on these, and a lot of companies are buying these. These little trucks, what they do is they spin the top there. It picks up that whole rack, so it brings the picking rack to the order assembly area. So a lot of distribution centers are starting to buy these. You can buy 4 of these for the price of 1 fork truck. And so the cost has really come down dramatically, but it's a whole different paradigm, isn't it? It's not get on the fork truck, drive out, bring a pallet back. It's go out. And by the way, they have these that'll work on full pallet loads as well. And so it's a different paradigm as is the autonomous pallet truck. So this is an autonomous pallet truck that found its way from this is a Vecna Robots, found its way to the pallet that has readers on it, and it pulls the pallet. So nobody goes into the bulk aisles anymore. The computer finds it. By the way, when computers put the product away, there's almost never a day that comes up that says, gee, I know we have it, but where is it? Because you took the human out of that, and there's no mistake now from the human perspective. This, of course, has now given us the ability, because the cost of these autonomous or semi-autonomous vehicles has come down so much relative to the price of everything else. There's almost no need in a manufacturing company not to have ultra narrow aisles anymore. So this is an example. That's a swing reach truck. It's an autonomous swing reach truck. So Raymond makes one of these. You got a console. I'm probably, the way this picture is taken, I'd be sitting at the console, and I would just say, go get me part number 13-748-00, and it knows where it's at, and it goes and gets it, left or right side of the aisle, raises up, gets it, and it brings it back to me. And so you can still do man aboard sort of fork trucks, where as soon as you get into the aisle, the computer takes over and you take your hands off the steering wheel and you just go and follow and verify. And but quickly, we're starting to find that we don't need human beings in most warehouse aisles. We now have the technology to eliminate that. This little robot, you can, again, the QR codes there, you can take a snapshot of that. This was in development for about 7 or 8 years, prototype for about a year, and then first small production run of these. And now we're starting to see them start to sell, and there's a couple other brands. So this is actually goes to the rack. It's interesting, it's cantilevered. It never falls over, it never trips. It drives to the rack, goes and gets the boxes for case picking, and then it brings it out and puts it on the pallet. So not just pallet stacking, it actually goes and does the picking of the boxes. I've actually watched this little guy in action, and they have different sizes of them, and they're pretty amazing. It used to be this, you'd have a person go, bring out a pallet, then you'd stack it on a pallet with maybe with other items. This now can run in and out of the aisles, and it can optimize for distances and locations through appropriate warehouse management system. And it can actually go and bring the material. This is not science fiction. There are warehouses now that have these, and there are not many of them, but we're really in the embryonic stage in terms of full use. But the future looks very promising. 5 years from now, these will be commonplace, at least in the case picking environment.
It's going to completely transform warehousing, it seems. So it'll be interesting.
Well, you know, Lisa, warehousing, we have not spent a lot of time and money and energy on this, and yet if you take a look at consumer products, about 14% of the total cost. That's kind of a minimum. It's probably higher than that now because of fuel prices and things. 14% is logistics cost. It actually exceeds labor cost in most companies. You know, I remember at our panel that we did with NESCOM that you moderated, we had the gentleman on there, Dan Ratchis from King's Hawaiian, and he flat me the numbers that said his logistics costs now exceed labor costs in his entire all of his factories. And so
Wow.
it's getting expensive to get product from point A to point B, whether it's inside of a warehouse or through trucks. Pretty soon, you know, if you go back, there's no reason why this can't be used to hand stack a truck and get
Right.
and eliminate the pallets. So yes, your point is a good one, because we are absolutely going to see a revolution in warehousing. And it started on both sides of the Atlantic. So in Great Britain, Okata, I've actually been in this warehouse. And the origin of this idea was you take warehouse racks, and somebody said, what if you laid them on their sides? And what if you had a robot that picked parts down, and you put parts in bins and things in bins, and this is for a grocery chain, and you with a suction device or some other grabbing device, you pick them up. And then what if you have thousands of those? So think about the rack. All the racks are laid on their side. You don't need aisles because they run over on these rails. And you look at those, there's hundreds. In fact, they actually have about 1,400 of them in that particular warehouse. And so you control them by software that was inspired by the air traffic control system. And it's they reached out to the US FAA on this to see if they could find a way to use some of that technology.
Very interesting. And Alan, we had a question. Will you be able to send us the slides when you're done as well, so we can
I'll send you the
post
PDF
them?
of this.
Thank you.
Yeah, and then by the way, when you get them, you can still go through and use your QR codes and read. That leads to a great story about this warehouse and how fast it is. And then of course they have intelligence, so they know when they're running low, because they're all battery powered. They know when they're running low, and they're finding their way to that back row back there, which is about 50 chargers back there, and they just pick a charger. So they're very intelligent. Wireless technology, complete rethinking of the speed. So they've cut the cycle time for filling a truck load for a grocery store. They've reduced it by 60%. So if you think about warehouse, you've got the receiving, you've got the storage, you've got the retrieval, you've got the kitting, we call it kitting or order assembly, and then you have the distribution. Those are the 5 major physical functions in any sort of warehouse. Picking has always been the retrieval from the racks or from the storage has always been the largest, most expensive component. Because think about it, you put away in bulk, but you pick individually. And so the retrieval or the picking has always been the largest cost of most warehouses. It's also been where most errors are introduced into the system because it has the most people and the most transactions. The more transactions you have, the more errors you're going to have. And so when you put away in bulk, you have fewer transactions put away than you have retrieval. And so they said, well, we have to do something to really focus. And that's what they did here. And so underneath is another layer of bins, and below that is a layer of, so it's a just-in-time, but think about just-in-time bins, but they're vertical. And when one's empty, it pops out, and the other one springs up, and these things just keep going. 24 hours a day. At this level, they now are to the point in this particular warehouse where only 1 out of every 5 lights is turned on because they just don't need the lights. It's a pretty interesting technology.
Wow.
Yeah, so we're seeing some real shifts here. So let's go to transportation and talk about what's going to happen in transportation. There's this whole debate about electric cars and hydrogen fuel cell cars and things like that. Here's one of the problems that we have to deal with. There is an enormous network of gasoline fueling stations in this country, and for the most part in every country. So transportation isn't just about the power source, it's about the reload source, where you reload the energy source. And so, and anybody who has an electric car knows you don't go somewhere that you haven't been without getting on your phone and looking up where the charging stations are at, because you may need one. However, there is a segment of transportation, trucks running from distribution center A to 5 stores down the road, or say buses in the city. And so they always have the ability to go back to a depot. And so we refer to it as depot fueling. So the depot fueling network doesn't need to keep things running, doesn't need them. So you can depot fuel in natural gas, electric, hydrogen, or diesel, and you can do that very efficiently and very effectively. The cost structures, if you can do this with hydrogen, natural gas, or electric, the cost structures will drop dramatically, because again, these aren't looking, you don't have to build, you don't have to have a lot of capital investment. So right now, to have the convenience of gasoline fuel stations, if you have a Tesla, we need to build a network of charging stations equivalent to that of the fueling stations. Well, it took 100 years to build the fueling station network. And so we're not going to build an electric recharging network. We're not going to build that quickly. It's very expensive, because now you have a whole different means of moving the fuel, not by truck, but by the power grid. And we don't have the power grid. I mean, there's lots of studies on this that are largely being ignored. And so the idea is in the market segment that's not consumer automobiles, but is depot fueling vehicles, this is where you're going to see the new technology take off. Already, we've been at natural gas depot station development for 25 years now, and we have plenty of those where it matters. Electric, not so much. Hydrogen, hardly any. I think in California, there's 3 hydrogen fueling stations. And diesel, of course, is ubiquitous and it's everywhere, but it's also what we want to get rid of if we can. So cost structures are going to shift dramatically. The reason Tesla is so interested in their 18-wheeler, electric 18-wheeler, is because there's only so many truck stops. There's a fraction of the truck stops in the United States as there are gasoline stations. So it's a much smaller capital investment for them to dominate the big rig trucking industry with the big rig electric vehicles than it is for consumer vehicles. The other thing is that we're seeing in the big trucks is we're seeing all kinds of technology. Electric trucks, it doesn't stop there. So autonomous trucks, I've actually seen autonomous trucks on Highway 10 between Arizona and Texas. I've actually seen them in test. I've driven on 10 a couple times. I have a son and a daughter who live in Texas, and so I've driven stuff back and forth to them all the time. And I've actually, for the last 3 years, I've been seeing quite a number of these. This picture is in Europe. These are Scania trucks. And so the first one is a driver truck, and the ones behind it are all autonomous. The ones behind it are, they call it platooning. They're following this truck. And so in a sense, you reduce the labor cost from 4 drivers to 1 driver. And so this is an interesting, and again, they go to a singular truck stop or fueling station. So the platooning or the autonomous or semi-autonomous nature of these is much easier to implement than it is with cars. It turns out this is probably where we should probably be thinking about dominating in electric vehicles first, in a depot fueling and an autonomous truck, and probably platooning is a good one. It's the results of platooning have been pretty good. Europe already allows platooning of trucks on certain highways. It's already been approved. Of course, drone deliveries have been talked about. We didn't think much of it. We talked about, gosh, how many thousands of drones would be in there? Well, you saw the warehouse with hundreds, if not thousands, of picking devices. So this ought to be workable. FAA's finally worked out and where they can go, and so they've now won approval to do this. There's other. Well, in a minute, I'll show you some other uses of drones. But I did a test with one of my clients where we had a company on the other side of town, 8 miles away, who made small printed circuit boards. These were actually the solid state single board drives, computer storage. So they're very small. They're half the size of a business card, terabyte of storage. And they made them, and they then put them in a cassette, which they dropped into a box, which was connected permanently to the drone. The drone then, from that workstation left, found its way out through the shipping doors of the factory, flew to my client, over the city, not following the roads, just going over the city, straight line, the way the crow flies, and then flew into the receiving dock and to the workstation and set down and turned off all its motors. And the worker came over and pulled that out. It then got up and it left and went back. And all day long, they were able to deliver every 2 hours boards to that assembly line. And that was really interesting. So there's some real opportunities here.
That is really interesting.
Yeah, so we're going to see more use of drones for what's going to drive the use of drones in supply chain is going to be JIT concepts off the road. In other words, just fly directly over everything. And so you'll probably see the growth of this with local suppliers, 5 to 10 miles away, where they can't locate right next door because there's no real estate or whatever. We actually have another client in Mexico that we're working with right now. Oh, no, I tell you, we did have a problem in Mexico that one day the federales shot one of those down because they thought it was drugs coming in across. We actually have a video of a drone, and all of a sudden it just spirals to the ground and crashes. And later on, we found out it was a federale that shot it down, and not knowing really what. So we learned a lesson that you can't use these without the community knowing what you're doing. So that was an important lesson.
Interesting.
So at Caltech, we deal with some big problems all the time. One of the biggest problems in Southern California for emergency technicians, paramedics, et cetera, is just imagine, for those of you who understand Southern California, imagine if you're in the Sepulveda Pass and there's a major crash. How do you get an ambulance to the Sepulveda Pass when you've got 5 miles of backed up vehicles and no emergency lanes? And so if you take a look at, you've got a number of freeways in California that are that way. Well, the idea is you fly a autonomous or semi-autonomous ambulance, and so they get the coordinates of where the accident is, and they can do that by satellite. That ability exists today. They can spot that accident by satellite. They can get the exact coordinates. And then this thing can take off from a hospital across town. It can fly out, find an area, the best area to land, and the EMTs either inside it or are already there can get out, take care of the patient. So this is a 4th scale model. The full scale prototype is in development. Will probably fly next year, and they'll give that a test. And so this could rewrite how fast we get to people, who are in deep trouble, and also, by the way, could also be used for search and rescue in deserts and mountains and everything else. So, but primarily it's about how to deal with gridlock in a completely unique new way. Speaking about unique new ways, the big picture on the right, that's an it's a Walmart warehouse, and that drone inside is going up and down the aisles, taking inventory. It's just scanning all the license plates on there, verifying that it's a full load because they know what the dimensions are. And so now when we do inventory, we don't have to get out the order picker or the man aboard or the ladders or whatever. We don't have to go up anymore. So you can do this, and it just flies up and down. And by the way, it's one of their ways of doing cycle counting. So they have manual cycle counting, but this thing in this particular warehouse, every single night after everybody's gone, they only run 2 shifts. On the 3rd shift, it just takes off and flies, and everybody's got the data when they get in the morning.
That is pretty brilliant.
Yeah. The bottom picture here is really interesting. And so I gave you a website there called www.alanaid.org. That has nothing to do with me. That's the American Logistics Aid Network. This is a nonprofit organization that in times of catastrophes and natural disasters and things like that, they have contracts with all kinds of logistics companies, helicopters, planes, trains, trucks, to be able to get supplies into disaster areas. This is really a fabulous organization. I contribute to this organization because this organization knows how to mobilize in times of disaster. So you see the pictures of how they get bottled water and stuff to, when there's a major hurricane or something. They use ALANAID as one of the biggest support networks out there. But now they actually are using drones to move emergency first aid equipment. This was a picture, I got this off the internet, but I know the guy who took it. And this was delivering first aid to some responders during Hurricane Ina. And so this was actually, they've done it before on 2 other hurricanes. And so you got responders out in the field, and they need to have their first aid kits replenished. So they fly a drone out with them and deliver them out there. So this technology has enormous potential, as does in the transcontinental shipping industry. Evergreen leads the way. Evergreen should be a company you know about. It's a major shipping company. It's a Taiwanese-owned container shipping company. They were the ones that blocked the Suez Canal, and they've had some other issues as well. But these new ships, so there's actually 2 ships now that are being built, but these are the 2 biggest right now that are floating, Ever Ace, and another one called Ever Act. I think this is the Ace. And so this ship holds almost 24,000 20-foot containers. A TEU is a 20-foot equivalent unit, it's a container. So if you think about that, it's about 12,000 40-foot containers. Today's cargo value exceeds $2 billion for one of these. So economically, in a wartime, if somebody sinks 3 or 4 of these, you've affected global economy dramatically. And so there's actually 2 ships now being built that are actually slightly larger than this. And these have changed the economics. Now, part of the reason we had a transportation problem, a shipping container problem, is that these ships really cannot afford to run half full. And so these large ships during a good portion of the pandemic were actually pulled off. And the reason is they couldn't get containers. The shippers couldn't get containers. All the containers were in the wrong spot. We had that bullwhip effect of supply and demand and transportation. And so these ships were parked for, I think 11 months, if I remember correctly. It was 11 or 12 months, the big ones. And so now things are getting back to normal. If you remember, the 2019, the shipping container might have been $1,700-$1,800 from Asia, went up to $20-some thousand. Now we're all happy because it's about $9,000, and it'll come down. It'll come down because size really matters, in the ocean. If you can get these, stack these containers. By the way, I've actually been on the Ever Act ship, and those containers, they're not sitting on a deck above the word Evergreen. They go all the way down to the water line. So this ship you take those containers out of there, it's just a big hole in the ocean. It's really amazing technology. The other thing in terms of automation, shippers are starting to understand, and technologists are starting to understand, that the first opportunity for Hyperloop is not moving people, largely because of the risks. There's a lot of work to be done on these yet. There's a big Hyperloop test track test tube up in the upper desert of California. There was a small link straight one in Torrance. They're taking it out now. I think SpaceX needs the land. But the idea of being able to put cargo in a tube and ship it is going to be really amazing. In fact, there's actually some discussion because they now have approved the new inland port in Mojave, California. And that's going to take up through the Alameda Corridor train. So we unload containers off of a ship in the port of Long Beach and port of LA, put them on a train, goes all the way to Mojave, just the longest, biggest train you can take. And then they do all the processing up there and the break bulk and then send them out across the country because there's pretty good distribution highways and things up there. That's really interesting. But there's some people said, instead of building a train, why don't we build a Hyperloop? And if you build a Hyperloop, it's an 11-minute ride. Takes 11 minutes. Takes it longer to offload it off the ship than to get it from Long Beach to Mojave. And so it's an unproven technology, although there's a lot going on here. At 5 years from now, you could have a test track along the Alameda Corridor all the way to Mojave. You could have that not used commercially, but you could be there. So this has some real interesting opportunities to it. Let's talk about robotics. Let's move this along and really spend some time talking about robotics. So the real value of robotics in factories is the ability to retool digitally and to redirect digitally, and this is all to support agility. So the whole point of robotics is not to take out labor. That's not the point. The real value is that you can introduce model changes faster than ever before because you're only retooling electronically. And so if you think about CNC machines with palletized setups, now you have the palletized setups put together by robots, turn the lights off in the factory, let it run. So we're going to see a lot of work on robotics, but it's not, all the studies to point this out, it's not going to be a desire in manufacturing to reduce labor costs. It's going to be a desire to increase flexibility and agility. That's what's going to drive it more than anything. Now, this is the value. We've learned this from welding. There's over 75,000 smart welding robots just in the United States, and overseas a lot more. But these are smart robots that work together. So any one of these, well, actually in this picture, because I know the source of this picture, the two robots on the left side are doing completely separate welding operations, but they can be used interchangeable. So if something happens to one, the other one's smart enough to know, and it just goes over there. The other one then backs away, and it can do them. Same thing with the right. So there's actually two robot banks here in this picture. The point is they can back each other up. And so there's real smart, well, and by the way, the weld quality out of these kinds of welding robots is so much better than the weld quality of most humans. The humans that do it, as well as the robots, are about 20% slower than the robots. So this is one of those technologies that is existing today. It's not nearly as expensive as most people think, and it's really designed to improve flow, not to take out labor content, but to improve flow, because you got a 20% pickup on flow. The tack times go down, and so this technically these are really a no-brainer if you're doing fabrication. Volkswagen developed the concept of smart and network production hand tools. So these are tools, they're wireless. And so as imagine you're working on an auto assembly line, and your job is to put a bolt in and to tighten it. So they're automatic torque wrenches. They beep, they won't work. Once you hit the right torque, you can't do more. The important thing is they also know at that workstation, there's 5 bolts you need to put on. If you don't put one on, you miss one, it tells you. And so they're actually smart. They actually keep track of what's been assembled and what hasn't been assembled. And so there's various levels of these. So the one in the center, to go forward or reverse, you just have those 2 blue buttons at the bottom. The one on the left has more of a traditional ratchet look at the top, and same with the one at the top. And so you have to manually determine whether you're going left or right. But these are now well adapted. There's over a dozen manufacturers of these now, including all the major manufacturers of hand tools, all have a line of smart tools now. And they're wireless, so they also can communicate back to a system. So now the work order now says those 4 bolts were put in, and the bolt A was torqued to 29 pounds, B was torqued to 29 pounds. It knows the operator from fingerprints on here, a finger reading. So it knows exactly the operator that put it. Think about that, you manufacturing managers. When somebody says, well, who left out that bolt? Well, you don't ask the employee anymore. You just pull it up on the system and it says, Ralph left that bolt off or didn't torque it right. Some companies like Scania, that truck manufacturer, was doing the platooning. This is one of their facilities. It's not a very good picture because it was taken with their security cameras, because they don't allow cameras in there, but they forwarded us this. And everything, and if you notice, this is actually, you can't tell because it's not a movie, but this is in full production. It's working, and you can't see a human being in the picture. And so material handling is done. The robots not only do the work, but they take and they move it over to the next area as well. So they've got all the work centers set up close. In fact, I talked to one of the industrial engineers and about how you decide where to locate your different robots. And he said, he just held his arm out and he said, we don't ever want a robot to be any farther away from another robot than the length of a human's arm. He said we use that as our rule of thumb in order to get the robots placed. And then we design the factory so nothing hits each other. The 4th issue we talked about were repetitive tasks. This is not just in the factories. This is in everything, including office-based jobs. So if you want to read a good book, go read Ravin Jesuthasan, spelled just like it sounds, Jesuthasan. Read his book called The Future of Work. You can get it on Amazon. And he says the people that are not going to have a good future in this world are the people who do repetitive office work. There's not going to be a need for them because we're going to have automation technologies and we're going to have skills driven by algorithms to do their jobs. That's one of the reasons why picking and packing and shipping and things like that in a warehouse are going to disappear. That's one of the reasons why we're going to be able to move inspection onto machines so that it doesn't have to go to a quality control inspector who gets out, gauges and measurement devices. It'll be done on the machine that made the part and then provide that data into the information system. And so we're going to see an enormous increase in the use of algorithmic intelligence systems that are going to be used to reduce repetitive tasks. Now, the one area where we're seeing We're seeing huge increase in robotics. This is really happening fast now, is in fast food restaurants, and even some non-fast food, but mostly fast food restaurants. And this is a company, Miso Robots was developed, grew out of Caltech, a bunch of bright grad students, watched how things were done in the grill area. Grill on one side, usually the fryers behind the person for the French fries and stuff. And they looked at it and they said, it's nothing but repetitive motion over and over and over. Why are we even having labor? And the answer was labor was cheaper than the cost of capital necessary for robots. When the cost of capital started coming down and wages went up, and now that in California, we've introduced the fast food wage concept, which makes fast food people make a whole lot more money. They singled out a single industry and gave them a different minimum wage expectation. It's kind of crazy, but that's the case. Well, now all of a sudden, this is cost effective. So White Castle, we don't see many of them here, but you go to the Northeast, you see them everywhere. If you know White Castle, you know what a slider is. It's a greasy little hamburger. Perhaps there's a reason they call it a slider. But Miso Robots is now installing these, and so and what they've discovered is the hamburgers are better, because when you flip the hamburger, there's a thermal sensor in that spatula, so it knows exactly when to flip. It knows exactly the temperature. It flips it. And then, of course, it can change out the end effector from a spatula to a scraper, and it can scrape the grill down periodically so the operator doesn't have to do it. Then it flips around and it picks up the bins. So at White Castle, somebody loads the French fry and onion ring bins, but the robot pulls them out, dumps them, and then shakes salt on them. And so this is all driven by the cost of labor. They discovered, incidentally, it's improved the quality because it improves consistency. Technology today to take and put at every workstation, so this is an electronic assembly workstation, to be able to put on-demand videos to show people how to do things is now capable. There's absolutely no reason in most companies to have engineering drawings, prints, and things like that float around. This can be done electronically. I have pharmaceutical clients where a tablet goes out into the factory that follows the material in the factory, and they want to get paper out because paper can hold pathogens, whereas the tablet, you can wipe it down with alcohol or peroxide or something and make sure those pathogens don't exist. So the idea of paper drawings, paper documentation is disappearing rapidly. When you take a look at the cost of distributing the information, distributing the video, the cost of the monitor, it's a fraction of the cost of maintaining a paper system. So now you take this and you connect this with smart tools, and now it collects telemetry from the operator. Foxconn, which has incredibly low wage rates in Asia, is now retrofitting almost their entire factory. The iPhone factory, which is a factory of used to be about 1 million employees. I'm not making that up. 1 million people in a factory, very large factory. Now they're moving to smart telemetry, because if there is a problem, when they do their diagnosis to figure out what caused the problem, they can go back and figure out if it was a person, if it was a faulty component, it was a faulty process, they did something out of sequence. So the show, demonstrate, view, do sort of logic is now with us. Another thing that Caltech, I use Caltech a lot just because it really is a school full of rocket scientists. I mean, they've got 10 or 12,000 applicants every year for freshmen. They only accept about 200. And every one of these kids, in fact, last year, over 80% had perfect SAT scores. That was just kind of crazy. So these are really, really bright people. These are a bunch of PhD candidates. And so in one of the labs, the professor has decided that living a life in a wheelchair is just unfair. And so he said, how do we get people up on, how do we reinvent the wheelchair? Well, first off, you stop thinking about it as a chair and you start thinking about it as a mobility device, or you start thinking about it as an augmented mobility device. And so you come up with the exoskeleton. This is an old generation exoskeleton. Here's some of the new generation exoskeletons. Take a look at the picture on the right. That exoskeleton almost completely eliminates back injuries, because when the person's wearing it, it has sensors. When he has to step up, it actually, there's little micro motors in there that actually push him up. It's like having a Barca lounger at work, it kind of pushes you up. And the
Interesting.
person in the middle there, you can see that he's working overhead. So this is taking the strain off of his arms, this device. The one on the left there is made by a company called Sarcos Robot. That guy can pick up 1,200 pounds, routinely 1,200 pounds with that device. So that's an accentuator, a strength accentuator sort. And those are pretty common. We're starting to see everything you see here exists. If I go back to the prior picture, the new generation of this is only marginally larger. I mean, it maybe sticks out 3/4 of an inch from this lady's legs and thigh and body. So it's and it gives you the ability to walk. They now actually have people at Caltech, some students that who literally walk around the class that were wheelchair bound their whole life. Isn't that cool? This is what automation can do. So it has a great social opportunity. It also has great industry opportunities. What makes this possible? Micromotors, low-cost sensors, communication capabilities, new lightweight, low-cost, high-strength materials, and algorithms and software that help and are smart. We're going to see a dramatic reduction over the next 5 years for companies that invest in these kinds of tools. And then the last one is kind of decision making. So augmented decision making. This is a guy who's got a tablet. He's pointing it in the factory through the lens. If you took that away, this is actually what it looks like. But the system is now sensing vibration sensors and temperature sensors on equipment and establishing whether that needs to be serviced or not. So now the maintenance person just walks through the factory. And so now this is a technology that's going to finally get us away from interval-based maintenance. Interval-based maintenance is just say, okay, change the fluid every hundreds of hours, or change. And the trouble with that is sometimes under certain conditions, you're not deteriorating that fluid as much, you're not hurting the bearings as much. So this now gets us to more of gets us away from a interval sort of maintenance and gets us to a predictive sort of maintenance. So I can now look at this and see the temperatures temperatures and the vibration are all within correct parameters. Even though it says go and inspect that bearing, I don't need to inspect that bearing because I found proxies that tell me whether the bearing's okay. Temperature and maybe they call run out, and also vibration. So in a sense, this is Pokemon Go for industry, 100% driven by low-cost sensor technology. So I think I have easily 30, 40 old clients I'm not even working with anymore that are using these kinds of technology in maintenance. And by the way, if it works in maintenance, it's probably going to work in training as well.
Absolutely.
Yeah. So here's one of the other areas that's going to be really interesting. This probably be beyond 2027. So we talk about this, what really determines criticality. So the component's criticality in manufacturing is not determined by its cost and its usage. It's determined by the length of the supplier lead time, plus the supplier yield and quality variation, plus availability of alternate sources, plus knowledge of things that can impact the supplier. All of those data elements, except for number 2, can be easily obtained by anybody in a purchasing organization. If I'm a buyer, I know what my suppliers' lead times really are, irrespective of what they tell me. I know what they really are. I know about alternate sources because I'm in charge, or at least partially responsible for finding those. And because I have conversations with the suppliers, I know that supplier is in Buffalo, and in winter, Buffalo, New York might be hard to get a truck out of. The one thing I don't know is the internal supplier yield and quality variations on every machine and every work center in their factory that makes the parts that they then ship to me, or ingredients or whatever. That I don't know. It's that low-cost sensor technology back at the suppliers, not just in maintenance, but in actual quality data metrics that we talked about earlier. Now I have the ability to get my hands on that, and that fills in the last element of criticality. So now I can determine whether that supplier is highly critical or not so critical. So if you look at the matrix there, the 2x2 matrix, on the left side, you have length of lead time. At the bottom, you have yield and quality variations. Those are the supplier controllable variables. The problem is suppliers haven't been telling us their yield and quality variations. If you bought that supplier and brought them into your factory, you would immediately have that. So the paradigm is that supplier is just a work center outside of your factory. It's a work center that you pay in a different way. You pay in a single check instead of a check for rent, for machines, for maintenance, for labor and things like that. And so the idea is that entire supply base of yours, if they could give you, at least on the critical items, the items in the top right-hand corner, the high risk area where the lead times are long, the variations are wide, the number of alternative sources are low, and the environmental impactants or ecosystem impactants are high. That's the definition of a high risk component or a high risk ingredient. So if for those you could actually get the yield and quality variations real time from their factories, then you would know what whether that's really a critical item. Right now, you might have suppliers that every time they ship you something, it's good, but you don't know that to get 37 good ones, they had to make 100 and sort out all the bad ones. You don't, and that indicates a risky, because that means they don't know their process. They have no control of their process. You want suppliers that have as much control of their processes in their factory as you have in your factory. Actually, you want more, because purchase items are at the bottom of the bill of material, which means the risk rolls up and creates more damage. So and that's one of the ways of getting better on-time delivery. And from that, you can also then start sending the data. We already see companies, there's about a dozen software packages now that do this, that give the ability to have dashboards for quality in your own company, particularly if you use a statistical process control or some predictive quality assurance measurements. And it actually can send to the quality assurance manager at home at 2 a.m. Sorry, QC managers. It can send a ping on their phone and say, you've got a machine that's outside of the control limits. It's not producing bad quality, but it's outside of the control limits, the mathematically determined control limits. And so there's no place to run, no place to hide. Well, this can also be applied to your suppliers, except instead of pinging to your quality assurance person, it's pinging to your buyer or to your procurement person, who then can, the next morning, can get on the phone and start to determine if we got a real problem that's going to impact delivery reliability from that particular supplier. So this technology exists already today, and you can apply it in your own factories. But if you can't get number two, if you can't get the data from your supplier about yield and quality variations, then you're missing the big opportunity. Interestingly enough, all the technology for this is in place today. It's available to every one of you today. Maybe too expensive for some of you, but it's there. And the cost will come down over time, and we will start to see companies start to apply this. So just to kind of wrap this up, 22 through 27, 5 years is not your family's or your father's supply chain. We're looking for agility. We're looking for autonomous actions. We're using a lot of big data, and we have to sort through that. We have to be willing to experiment. We have new people with new skills. Everything's going to be disruptive. Man, I tell you, the last 3 years has been nothing but disruption. And I don't think it's going to get any better anytime soon. But then we have to find ways to take all that big data and some of those skilled people and to try to get some intelligence out of all this so we can make better decisions. Here's my final insight and thought. And this goes to the reason for ASEM and ASCM Inland Empire, and for all of you personally. To advance a global supply chain management disciplines, you are mandated now to be a forever learner. Just because you got your CPIM 15 years ago, just because you've gone to a bunch of conferences, just because you're a volunteer, doesn't make you knowledgeable of the opportunities out there today. Everybody listening to this needs to take personal responsibility for your own intellectual advancement and not rely mainly on your employer. This idea that employer is responsible for training me is only half the story. You're responsible yourself. Those of you who went to college, you know this. You did that for you, and you paid the bill, or still have the bill, perhaps. But so normally you understand this, but for some reason, people stop the learning, and that's one of the reasons why it's so important to belong to a professional organization like ASCM with professional people who think alike, act alike, and have all the same sorts of problems. The only difference now is that we're going to stop focusing on commiserating on the problems and start looking at everybody and going, that problem suggests an enormous opportunity. I want you to think about that. If I lived in Florida, I've probably been through a hurricane, and hurricanes are really bad things. If anybody has been through a hurricane, you know it's not a fun thing. But if you're the only roofer in town, hurricanes are enormous revenue generators for you after the hurricane. So it's important to understand, out of these kinds of problems and ecosystem issues that we've gone through the last 2.5, 3 years here, there's a lot of problems, and our employer is not going to solve all of them. You need to attend programs like this. You need to attend other programs. You need to read a lot, study a lot, get out, even if it's on your own nickel. You need to get out and start to see what other people are doing. Because you know what? Almost every problem that you're struggling with in supply chain, not all of them, but the majority of them have already been solved, but probably in a different industry. They've probably already been addressed somewhere else that's not related, that you wouldn't think about going to at all. So when you're looking for solutions, stop looking for the solution. Look for the area in society or an industry that might have some inspiration in it. And you might learn a little bit from one and take from another and put it all together. You have to be a lifelong learner. You have to be curious for the rest of your life if you're going to survive in supply chain, because every day the rule book runs out, and you all know that. You come to work and you say, I didn't see that coming. If you had the supply chain rule book in front of you, if you had the old Plossel White or the old Montgomery book on statistics, you'd go through it, you wouldn't find the solution, because the rule book does in fact run out every single day. That's why these kinds of programs are really important. With that, I'd like to wrap it up. If there's any time for questions, I'm more than happy to.
Yeah, we have a question, Alan, for you. Yeah, no, that was a great presentation. Got a lot of great feedback from folks. One question that's being asked here is how the semiconductor production in the US will help the supply chain industry globally, or will it, I guess is his question.
Yeah, great question. I had a discussion with an executive at Taiwan Semiconductors yesterday, or last night, I should say, my time. And so, yes, the growth in semiconductors in the US is going to definitely help us. It's going to help to solve the shortage problem. Companies are conserving on semiconductors right now. That is going to help us to the combination of the conservation of semiconductors. So, for example, I can't remember what Toyota, I think, is not going to is now has designed key fobs out because they don't want to use up their semiconductor capacity that they buy on key fobs when you can go back to keys. So they have a sense that that'll get them through this. So some conservation is important, but getting the wafer fabs and the back end assembly back to the US, especially because of the level of automation. We actually work with one of the largest equipment manufacturers, in fact, probably the largest equipment manufacturer in the semiconductor equipment business. These guys that make all the equipment to make semiconductors. And so we've worked with them, and we've looked at the worldwide logistics cost of semiconductors. So you make the wafer in the Philippines, you then send it to the Netherlands to be cut up, and then you send it to Malaysia to be packaged, and then you send it to a bunch of distribution centers to allocate out, and everything moves by air freight in that business. Nothing in the semiconductor industry in final product moves by boat or by ship or by truck or rail. It all, because it's not that heavy, so it all moves, by air freight. So the logistics costs tend to be fairly high. So one of the questions was, well, if you had in Tempe, Arizona, a wafer fab, and you had down the road from it, or maybe it's connected, you had the back end to do all the assembly, and you do it right there by Highway 10, so you've got distribution, you can get anywhere, or you can use airplanes still out of there. By taking out all those logistics and lost time, I mean, what's the cost differential between doing it there versus having it made by, Samsung in South Korea? And the answer comes up to less than 5%. There's less than a 5% cost advantage doing it overseas than doing it in the other. Think about what I just said, less than a 5%. So the question then is, can we do some automation to make up even that 5%? And by the way, maybe the question, are you willing to pay 5% extra for supply assurance? I think
Yes.
everybody they would say yes.
Yes,
today.
they should say yes.
Yes. Yeah. So that's look. The other thing to be talking about is Taiwan, and it's not a political discussion about why China wants Taiwan, but if China gets Taiwan, we have to remember they get the Taiwan Semiconductor Company too. And so this could create enormous problems. I'm not suggesting we go to war with China to keep them from taking over Taiwan, but we better understand in North America that if you take Taiwan Semiconductor out of the supply chain, I mean, look, Russia shut off fuel to Europe. China could shut off semiconductors to America too. I mean, so it's not out of the realm of possibilities. This is about risk management as well. Back to, would you be willing to pay 5% more? The answer, of course, is yes. So.
Yeah, exactly. And yeah, that'll be interesting. Well, I hope that doesn't happen, but to your point, there's a lot of risk. And it'll be interesting because when we have a fab and manufacturing in the US, although it's owned by Taiwan, I don't know.
Right. Well, yeah, there's some structural issues that'll obviously have to be addressed as well. So
Yeah,
any other
true.
questions?
Let's see, I had gosh, I got so interested in that last topic. Now I'm trying to remember my question, but I had a question for you. Do you see, do you think that what would you say would be the main thing that you're really looking for? It seems like the advancements in technology is really what you see that we should be paying attention to, but then at the same time, it really relates back to the skills that we have. Well, it sounds like, is that right?
Yeah, so partially right. So it's the convergence of the technologies. Almost every technology that I talked about is pre-existed for quite a number of years in commercial form. It's the convergence of those, and that convergence is why there's a necessity to upskill. And so that it's the convergence that really drives the talent base. And that's why everybody who works in the supply chain needs to be thinking about. So imagine if all of a sudden you're a demand planner, and then all of a sudden your phone is as powerful as the Watson computer to figure out extrinsic and extraordinary demands and maybe leading indicators before demand happens or before demand collapses. As a demand planner, big data analytics and ML and AI could change the way you do your job. And so the ability to get extrinsic information in there instead of relying purely on intrinsic historical data could change your life. The ability to get telemetry from a manufacturing environment and to say, okay, that's 4 levels down on the bill of material, and I can see that it's not going well, which means its completion date could potentially be predicted to shift out 3 days. That gives you the ability to think about replanning and scheduling those upper level items. And so the ability, that's that convergence that takes us away from purely reacting to prediction. Our life, certainly in the planning world, will move more from reaction to a predictive nature. And that's a different skill set, because now you have to make sure you understand the mechanism by which the prediction is being formulated. I mean, look, we just had an election, and there's a lot we learned out of that. I can actually give you a truism about this election that has nothing to do with politics. It's like not a single poll was right. So every pollster, left side and right side of the aisle, everybody was wrong, or at least they were enthusiastically lying. I don't know. But what I learned out of the election is never, ever believe a poll ever again.
That is very true.
It has nothing to do with the candidate. Has nothing to do with the candidates. It has to do
No.
with the pollsters. Something has changed in their world that they don't understand. You know, when forecasts are constantly wrong, that means there's something structurally different in the marketplace. You know, this is why understanding seasonality and trends is so important, because, you know, given 2 or 3 years of data, you can actually start to see some structural shifts in your marketplace. Apparently pollsters haven't bought into that. And they used to always say, you know, the poll would always say the plus or minus X% for the margin of error. And yet all the shifts were far beyond the margins of error in almost every major race. And so there's something structurally broken in the political polling. And I'm telling you something, if you used those kinds of techniques in public health, if you use those kinds of techniques in demand planning, you'd lose your job, because you can't constantly be wrong.
That's very true. Very, very true. Well, thank you very much, Alan. It was very timely. It kicks us off to be thinking forward for 2023, and it certainly talks to the importance of continuing to not only attend our webinars, but we're going to be launching additional training and education programs and certifications for 2023. So definitely get involved. As Alan said, we all have to be continuous learners, and that's what we're here for at ASCM Inland Empire. So thank you to everybody, and we will, we'll see you on our next webinar. And thank you very much, Alan, for taking the time and for all the dedication you've had with ASCM over the years, and also with our chapter, and of course, from our consulting points of view as well.
Thank you. Always my pleasure to work with you.